We like to tell ourselves that we live at the absolute peak of human ingenuity. We have skyscrapers that touch the clouds, quantum computers, and rovers on Mars. We assume that we are, without question, the most advanced civilization to ever walk the Earth. But what if we're wrong? What if scattered across the globe lie pieces of lost technology that modern engineers still struggle to comprehend? We are not talking about myths or legends. We are talking about physical, impossible engineering feats that defy our understanding of the ancient world. From massive stone jars moved without wheels, to water systems that used advanced physics in the middle of a desert, to bridges woven only from grass that rival modern steel cables. These aren't just impressive ruins. They are evidence of lost physics, lost chemistry, and methods that force us to completely rewrite the timeline of human capability. Welcome to Impossible Engineering. High in the Andes Mountains, the Incas faced a problem that would stump most modern civil engineers. They had an empire stretching thousands of miles, but it was sliced apart by deep, treacherous gorges and roaring rivers. How do you move an army, trade goods, and messages across an abyss that's hundreds of feet deep, where no stone foundation could ever hold? Their solution wasn't steel cables or reinforced concrete, it was grass. Specifically, ichu grass. To the modern eye, a bridge made of woven grass feels like a death trap. But the Inca suspension bridges, or queswachaca, were marvels of engineering that lasted for centuries. Here is where the physics gets impossible. First, they gathered millions of blades of grass, hand-twisting them into small cords. These were then braided into larger ropes, some as thick as a human body. These ropes were so heavy that it took entire communities to drag them across the canyons. They didn't use anchors in the modern sense. They carved massive stone abutments directly into the cliffside, essentially turning the mountain itself into the foundation. What truly defies logic is how they handled tension and load-bearing. When a bridge is built with steel, it is rigid. It resists the wind and the weight. The Inca bridge was flexible. It moved, breathed, and swayed with the Andean winds. This flexibility actually distributed the stress across the entire structure, preventing it from snapping under the weight of hundreds of people or heavily laden llamas. It was a dynamic system, not a static one. Even more fascinating is the maintenance. The Inca knew these bridges were organic. They knew the grass would rot. So they established a perpetual cycle of reconstruction. Every single year, the local communities would cut down the old bridge and weave a new one from scratch in just 3 days. It wasn't just a construction project. It was a cultural ritual that kept the engineering knowledge alive across generations. Today, we view these bridges as primitive. But think about it. We build structures that require constant maintenance with heavy machinery, fossil fuels, and carbon-heavy materials. The Incas built a system that was fully biodegradable, renewable, and perfectly integrated into the environment. They didn't conquer nature, they collaborated with it. When we look at the queswachaca, we aren't just looking at a bridge. We are looking at a masterclass in material science that we are only just beginning to appreciate. Imagine standing in the middle of a furnace. The desert sun in Jordan is relentless. The ground is cracked, and there isn't a river for miles. This is Petra, the heart of the Nabataean kingdom. 2,000 years ago, this place wasn't a barren ruin. It was a thriving, lush metropolis of 30,000 people, complete with fountains, gardens, and swimming pools. How? Because the Nabataeans didn't just find water, they engineered a way to own the desert. The Nabataeans were the undisputed masters of hydrology in the ancient world. Their system wasn't a single invention. It was a vast, invisible network of engineering. They didn't rely on one big source. Instead, they built an intricate web of dams, cisterns, and terracotta pipes that stretched across the entire landscape to capture every single drop of seasonal rainfall. They understood topography like no one else. Think about the scale for a moment. To bring water into the city through the narrow, twisting canyons, the Sikait, they carved channels directly into the cliff faces. These weren't just simple gutters, they were precisely sloped channels. If the slope was too steep, the water would move too fast and erode the rock. If it was too shallow, the water would evaporate in the heat. They calculated these gradients with a precision that makes you wonder if they had modern surveying tools. But here is the impossible part, the pressure. In sections where they needed to move water across valleys, they used an inverted siphon system. By forcing water through sealed terracotta pipes, they created enough pressure to push it uphill and across depressions. We often credit the Romans for their grand aqueducts, but the Nabataeans were mastering complex fluid dynamics and pressurized systems centuries before the Romans reached their peak. They also built hundreds of underground cisterns, hidden from invaders and the scorching sun. These chambers were lined with a special waterproof plaster that has survived for 2 millennia. They essentially turned the entire desert into a giant, rechargeable battery for water. When the flash floods came, which are lethal in this terrain, the Nabataeans diverted that destructive energy into their storage systems, turning a natural disaster into their greatest resource. When we look at Petra today, we see the beauty of the stone carvings, but we are missing the real genius. The genius isn't in the facade, it's in the invisible plumbing underneath our feet. It's a lesson in extreme resource management. In a world where water scarcity is becoming our biggest challenge, the Nabataean approach, capturing, storing, and moving water with gravity and minimal waste, feels less like an ancient curiosity and more like a blueprint for our future. Deep in the mist-covered mountains of the Shangquang Plateau in Laos, there exists a landscape that feels like it belongs to a civilization of giants. Thousands of massive stone jars, some weighing up to 6 tons, are scattered across the hillsides, sitting in clusters as if they were left behind by a civilization that vanished in the blink of an eye. This is the Plain of Jars, one of the most enigmatic archaeological mysteries on the planet. When you stand next to these jars, the first thing that hits you is the sheer scale. They are carved from solid stone, sandstone, granite, and limestone, with hollowed-out centers that are perfectly circular. Many reach over 3 meters in height. But here is the impossible engineering question. How did people, thousands of years ago, transport these behemoths from quarries miles away? And more importantly, how did they hollow them out with such precision without the use of metal chisels or advanced machinery? Modern archaeologists have found the quarries, and the distance is staggering. Some jars weigh as much as a heavy-duty truck today. There were no roads, no cranes, and certainly no fossil fuel-powered engines. The logistics of simply moving these from the quarry to their current resting places implies a level of social organization, labor coordination, and physical strength that we struggle to wrap our heads around. It suggests a society that possessed a master plan, a blueprint that has been lost to the sands of time. Then there's the question of purpose. For decades, legends claimed they were cups for giants to drink from. Others theorized they were massive water storage units or vats for food preparation. Recent excavations, however, point toward a more solemn reality: funerary rites. We found human remains and burial goods inside. But even if they were for burials, the engineering remains just as baffling. Why spend years carving a 6-ton stone vessel just to hold the departed? The level of reverence and the sheer intensity of the effort involved reflect a culture with a deep, sophisticated relationship with both life and the afterlife. Perhaps the most haunting aspect of the Plain of Jars is what we don't know. Unlike the Romans or the Egyptians, who left behind records and inscriptions, the makers of these jars left no written word. They are a silent monument to a society that operated outside of our documented history. They challenge our assumption that progress is a straight, upward line. It's a sobering reminder that sophisticated societies can rise, thrive, and disappear, leaving behind only these stone puzzles as their final, silent testament. When we look at these jars, we are forced to admit that our modern way of building isn't the only way. There are techniques of stoneworking, organization, and logistics that these ancient people possessed, secrets that allowed them to shape the very mountains to their will. The Plain of Jars isn't just a gravesite, it's a mirror. It shows us that there is a vast, hidden history of human capability waiting to be rediscovered. A reminder that we are just one of many chapters in the long, mysterious story of human engineering. Deep within the scorching, desolate eastern desert of Egypt lies a place that was once the most precious location on the Roman map. This is Wadi Sikait. To the untrained eye, it looks like just another cluster of crumbling stone ruins baking in the sun. But beneath the surface, hidden in the labyrinthine tunnels carved into the mountains, lies the source of the world's most coveted gemstone in antiquity, the emerald. These weren't just simple holes in the ground. Wadi Sikait was an industrial complex, an underground city built by the Romans to extract green fire from the earth. The engineering required here is staggering. When you descend into these mines, you realize that the rock is soft, treacherous, and prone to sudden collapse. Yet the miners carved miles of tunnels, galleries, and support structures that have defied gravity and time for nearly 2,000 years. How did they manage the structural integrity of these shafts without modern steel beams or hydraulic shoring? They employed a genius understanding of load distribution. They carved natural pillars, leaving columns of native rock to support the mountain's weight. Furthermore, they managed thermal regulation in one of the hottest places on Earth. By engineering the tunnels with specific ventilation shafts, they channeled cooler air from the surface into the deep subterranean workrooms, keeping the temperature tolerable for the thousands of laborers working in the dark. The logistics of this site are equally impossible. Wadi Sikait is incredibly remote. To keep this operation running, the Romans had to create a lifeline across the desert. They built a sophisticated system of cisterns to collect and store water from the rare winter rains and organized long-distance supply caravans. This wasn't just mining, it was an exercise in extreme, large-scale survival engineering. They turned a hostile, barren wasteland into a highly productive economic engine. What fascinates me most is the human element that remains. You can still see the stone huts where the miners lived, the small shrines they built to pray for safety, and the intricate way they marked the veins of emeralds in the rock. It's a stark contrast to our modern, automated, and digitized mining processes. Their engineering was manual, slow, and risky, yet it was undeniably precise. It relied on a deep, almost intuitive knowledge of the Earth's geology. When we look back at the mines of Wadi Sikait, we are looking at the roots of our industrial ambition. We often think of the Roman Empire in terms of colosseums and grand roads, but the true grit of their civilization was found here, in the dark, silent mines where they conquered the desert to reach for beauty. It reminds us that impossible engineering is often just a matter of persistence, clever adaptation, and an unwavering belief that even the harshest environments can be made to yield their treasures. For centuries, we've been told a very specific story about human progress, that the ability to purify water, to remove heavy metals and pathogens, is a modern triumph of the 20th century. We point to our massive treatment plants, our complex chemical processes, and our high-tech industrial filters. But what if we were looking in the wrong place? Deep in the jungles of Tikal, the ancient Maya were solving this problem over 1,000 years ago. And they were doing it with a level of sophistication that genuinely shocks modern science. The Maya lived in a tropical environment where water was everything. But the water in their reservoirs was often stagnant, full of toxic algae, and contaminated by the heavy minerals found in the limestone bedrock. To survive, they couldn't just boil their water. They needed a system that could handle volume and chemistry. Archaeologists recently discovered something incredible at the Corriental Reservoir, a massive engineered filtration system buried beneath the earth. This wasn't just a pile of sand. They constructed a series of layered multi-material filters. When researchers analyzed the layers, they found coarse sand, fine sand, and most importantly, crushed zeolite, a naturally occurring mineral that acts like a molecular sieve, and crystalline quartz. This specific combination is exactly what we use in modern water purification to strip out lead, chromium, and other industrial toxins. The engineering feat here is twofold. First, they understood the chemical properties of these minerals. They knew exactly which materials would trap bacteria and bind to heavy metals. Second, They engineered the physics of pressure. They designed these filters to be pressurized, forcing the water through the layers at a rate that ensured complete purification while maintaining a constant flow. We used to think they were just storing water. In reality, they were operating a high-capacity, gravity-fed treatment plant. Why does this matter today? Because it forces us to rethink our arrogance. We treat our ancient ancestors as if they were simple, manual laborers struggling to survive. But the Maya were scientists. They were performing advanced chemical engineering before the concept of a laboratory even existed. They didn't need electricity or plastic membranes to provide clean water to their entire city. They used the earth itself. When we look at Tikal now, we shouldn't just see the famous temples that touch the sky. We should look at the earth beneath our feet. The Maya weren't just building a civilization. They were building a sustainable, long-term machine for living. Their water filters are a silent, incredible testament to a lost science, a reminder that nature has already provided the solutions. We just had to be smart enough to arrange them. If you fly over the vast, barren deserts of the Middle East, there is something you won't see from the ground, but it becomes undeniably clear from the air. Across thousands of miles of arid landscape, there are massive geometric shapes etched into the earth. They look like giant, sprawling patterns, or perhaps some kind of ancient land art. Archaeologists call them desert kites because of their shape, long stone-walled runways leading into a triangular enclosure. But these were no toys. They were one of the largest, most ambitious engineering projects in human history. For a long time, we didn't know what they were for. Some thought they were animal pens, others thought they were traps for warfare. But as we've mapped them, the sheer scale has revealed their true purpose. These were sophisticated, mass-scale game drive systems designed to exploit the natural migration patterns of desert wildlife. They are essentially giant funnels. Two long, low walls, sometimes stretching over several kilometers, converge into a narrow gate, leading into a hidden pit or an enclosure. Here's where the engineering gets impossible. To build these, you don't just need a group of people. You need a massive, unified society with a singular vision. These structures are spread across entire countries, from Syria to Jordan to Saudi Arabia. They require thousands of tons of stone to be moved and stacked. The builders had to understand the topography of the desert perfectly, knowing exactly where to place the walls so that animals wouldn't see the trap until it was too late. It's a masterclass in landscape architecture. They weren't just moving rocks. They were re-engineering the desert environment itself to make it work for them. These structures show that thousands of years ago, humanity possessed a level of logistical coordination that we often reserve for modern states. Imagine coordinating a project that spans hundreds of miles of inhospitable terrain without GPS, without maps, and without heavy machinery. It speaks to a lost organizational genius, a society that could move mountains to feed its people. But why are they so invisible? Because they are low to the ground. They were designed to blend into the landscape. This is the ultimate passive technology. Unlike our modern fences or industrial enclosures, these kites used the land itself as part of the machine. They reveal that the ancients viewed the environment not as an obstacle to be overcome with brute force, but as a component in their design. They didn't fight the desert. They incorporated the desert into their architecture. Today, the desert kites are fading back into the sands, but they remain a profound question mark. They challenge the idea that hunter-gatherer societies were primitive or disorganized. When we see these kites from above, we are seeing the shadow of a forgotten era of mastery, a time when our ancestors saw the world not as a map to be walked across, but as a canvas for large-scale, impossible engineering. Imagine walking through the blistering heat of a central Persian desert in the middle of July. The sun is a white-hot orb, the air is dry enough to crack stone, and the temperature is well over 40 degrees Celsius. Now, imagine walking into a structure that isn't connected to the power grid, has no electricity, and no modern refrigeration units, yet inside, there is ice. Not just a little bit of frost, but solid blocks of ice preserved from the winter. This isn't a fantasy. It's the Yakshal, an ancient Persian masterclass in thermodynamics. These structures look like giant mud brick domes rising out of the desert floor. To the untrained eye, they might look like temples or defensive bunkers, but they are actually massive, passive cooling machines. The construction itself is the genius. The Persians used a specialized water-resistant mortar made of sand, clay, egg whites, lime, goat hair, and ash. This material, called sarouj, had high thermal resistance, preventing the intense desert heat from penetrating the thick walls. But the engineering goes deeper than just the material. The shape of the dome is specifically designed to minimize surface area exposed to the sun. Even more incredible is the wind catcher system. These domes were connected to a series of underground channels called qanats. These channels would carry cold air from deep beneath the earth, circulating it into the dome. Because hot air rises and escapes through the top of the structure, the yakal created a constant, natural draft that pulled cold air in and kept the interior temperature near freezing, even during the peak of summer. The logistics of filling these ice houses were equally impressive. During the winter, water from nearby streams was channeled into shallow pools near the yakshal at night. The cold, dry desert air would freeze the water solid overnight. Before the sun rose, laborers would break the ice into blocks, carry them inside, and stack them carefully. They even layered the ice with straw to provide extra insulation. It was a perfectly choreographed dance with the elements, executed with a level of precision that we would struggle to replicate on a commercial scale today. When we look at these domes, we aren't just looking at ancient storage. We are looking at a profound understanding of heat transfer, fluid dynamics, and solar geometry. We have become so addicted to high-energy solutions, our electric refrigerators, our CFC-emitting air conditioners, that we've forgotten how to work with the physics of our environment. The Persians didn't need to conquer the heat, they simply outsmarted it. As our world faces rising temperatures and energy crises, the humble yakchal stands as a silent teacher. It reminds us that sustainable engineering doesn't always require a silicon chip or a complex engine. Sometimes the most advanced technology is the kind that works silently, in harmony with the planet, using nothing but the air, the earth, and the genius of human observation.